transaction and global transaction. Transaction means
Yes.
local transaction. Global transaction is when multiple resources are involved, right?
Okay. Yes. Yes.
So let's say you are having multiple transactions, right? Sorry, you are having global transactions, so something should be there which is going to manage these transactions, right? So there is a transaction manager. Okay, so Bitronics is a transaction manager which is available for XA transactions. Okay, which you
Okay.
can use for XA transactions, and you have to define this by using this command BTI, that is your transaction manager. Automatically it will be used for your XA transactions. You can search about Bitronics to see what are the advantages of Bitronics. Okay,
Mm-hmm. Okay.
otherwise your this sorry, XA transactions always use two phase, that is commit and two phase one, like prepare and commit.
Mm-hmm.
Okay, for Bitronics transactions the default timeout is always 60 seconds. Okay, so you can change this timeout also. Okay, so whatever I told you about the runtime properties yesterday, right? While deploying any application, you were providing the runtime properties by going to the property tab in the runtime manager, right? So
Mm-hmm.
there
Yep.
you can provide this property, that is mule.bitronics.transaction timeout, and you can change this default timeout to another timeout, which will be like 120 seconds or something.
Mm-hmm.
Okay, so while using the transactions, so as I told you, your DB connectors, your VM connectors, and your JMS connectors will only participate in the transactions, right? All
Mm-hmm.
other connectors cannot participate in the transaction. So what all options are there? Yesterday we have seen there was one option, that is none. Another option was indifferent, and another option was always begin. Okay.
Uh-huh.
So okay, so these none, this one is there only in the listeners, these listeners. Okay, that
Okay.
means we are not going to use any transaction, we are not going to participate in the transactions. Okay, and this will
Mm-hmm.
only exist in the listeners. Okay, indifferent will only exist in the try scope.
Okay.
Indifferent is always like never participate in the transaction or ignore the ongoing transaction. Okay, for listeners you are having this, but for try scope you are having indifferent. Yesterday also we have seen that, right?
Mm-hmm.
Let me show you that again. So let's say if I have, yesterday we were seeing this now in the try scope. Okay, so we were having these three options: always begin, because you can
Mm-hmm.
begin the transaction from event sources of JMS or VM, or from the try scope only, right? So
Mm-hmm.
always
Yeah.
begin, or begin or join. Let's say if there is any transaction, just join that transaction. If no transaction is there, then start the transaction. Okay, and the third one
Mm-hmm.
is indifferent, not do not participate in any transaction. Okay,
Okay.
let's go back and see. The third one is always begin. Okay, so always
Mm-hmm.
begin is there in the sources only. Okay, that is JMS, VM, and DB connector, and the try scope also. Okay, that will always start the new transaction, and in case there is any ongoing transaction before that, then it will give you failure, it will give you exception. So let's say if you are having this on on new message. Okay,
Mm-hmm.
in on new message you have set this transaction as always begin. Okay, and then you are having one try scope. Transform or you can have it like AB. Okay, and in the try scope, if you set always begin, then this will give you exception because there was ongoing transaction and you then said begin the transaction. Okay,
Mm-hmm.
so it means that local transactions cannot be the nested ones. We cannot nest any local transaction. Clear?
No. Can you
Okay.
repeat?
Yes, yes. So let's say if you are going to start any transaction from here, from the source,
Mhm.
you're saying
Okay.
that begin the transaction. Okay.
Okay.
So when it goes ahead, let's say there was one insert here, okay, and in insert it is participating in the transaction. Join if possible. Okay. So what it will
Okay.
do? Join if possible. That means it will join the transaction. Whatever transaction is going on, it will join it. And
Mm-hmm.
we are having one try block as well where I have written always begin. Okay, but
Uh-huh.
there is one transaction which is already going, right?
Yeah.
So and we are saying that begin the transaction, but there is already a transaction, so it will give you error. Okay, so
Oh.
the
Mm-hmm.
safest thing is begin
Begin.
or join. So if the transaction is already there, then join it. If the transaction is not there, then begin the transaction. Okay,
Got it. Got it. Yep.
so let's go back here. So it says that local transactions are not allowed. Okay, you cannot begin the transaction again and again. Okay, next is while participating, there is always join. Okay, now we are talking about non-listeners. Okay, non-listeners, always join is also there. So let's say i I'm having this insert. This is a non-listener one, it is not the source, right? So
Mm-hmm.
what
Yeah.
all options are there? You can see always join. That means if the transaction is going on, just join that transaction always. Next is join if possible. That means if there is any transaction, then you can join it. If there is no transaction, then leave it. Okay? Join if
I have one
possible.
question. Sorry.
Mhm.
So, when you open insert, we can see transaction like all three option like
Hmm.
always join, no support.
Hmm.
So why we use try again? Like if we have these options in the
We
in
are not
insert.
having begin the transaction here. We are just joining the transaction, right? The
Oh,
train is going on. You are just going, you are just trying to enter the train, right? Here. But you are not going to start any new train. Clear?
always join. Oh, start is not mentioned here. That's the
Yes.
difference.
But in the
Oh,
try block, what you can do, you can start the transaction, begin or
oh,
join.
begin.
See?
Okay, okay, I miss
Yes,
that.
always
Yes, yes.
begin. Okay. So
Okay,
from
yeah.
source and from try, you can begin the transaction. That is the most important difference.
Okay,
Clear?
all right.
And
Yes.
the third option here is here in the insert one is not supported. Let me go there. Okay, always join if the transaction is there, and if I am setting always join, then it will always join that transaction. Let's say if the transaction is not there and you have selected always join, then it will give you exception because it was waiting for the transaction but it haven't received any transaction, right?
Mm-hmm. Yeah.
Okay, join if possible means if the transaction is there, then join it. If the transaction is not there, then fine. Okay, so it will not give you exception in that case. Not supported means never ever join any transaction. Clear?
Okay. Okay. Yes. Clear now.
Okay, so this is what I have explained.
Uh-huh.
Manage the transactions using the saga pattern. Okay, so this XA is basically uses two phase, like that is prepare and commit. Okay, which will provide you all the ACID properties, right? And this is supported by few connectors only, that is JMS, VM, and your DB, right? Or using a
Mhm.
triscope. That's it. So what if there are some other connectors for which you want to build this rollback strategies, right? So
Mhm.
for that you can use the saga pattern. Saga pattern, like these patterns are just like your frameworks, like REST framework is there, right? So you follow some rules and regulations, that's it. It's up to you. You are having a framework, you want to use it in your own way, like that. Okay, so there
Mhm.
is one saga pattern. So saga pattern is alternative to your XA when resources are not XA capable or XA is undesired. Okay. For
Mhm.
instance, API invocation. Let's say you are having request connector, right?
Mhm.
So if you are having request connector, in that case, you can use the saga pattern. This is a way to achieve the reliability that does not have the ACID guarantees. So it does not provide the ACID guarantees because here you will be doing some complex coding. You are providing the rollback strategies. Okay.
Mhm. Okay.
Features of saga pattern includes maintains the consistency but not the atomicity. Consistency means if you are updating some in table 1, then that thing can will be updated in table 2 also. Okay, but atomicity
Mhm.
is not there. That means, let's say by mistake, if you have deleted that thing from table 3, okay, and while deleting from table 4, it may get interrupted.
Mhm.
Okay, so atomicity, that 0 1 thing will not be there.
Okay.
So it will not require any transaction manager system. So in that case, we were using Bitronics, right? Here, no transaction manager is required. So it uses basically the sequence of local transactions. Okay, so local transactions will be used with these saga pattern. Okay, failure of the local transaction executes a series of compensating transactions to undo the previous successful transition. So see how it is becoming more and more complex. One transaction, if one local transaction is getting failed, because of that, series of other transactions will be executed to do the rollback task. Okay, so
Mhm.
more complex programming model as compared to your XA. So this is how Saga event choreography pattern works. Like you are having one API, then it will send this, let's say you are having one database or something, you are providing the status that order was successful, then payment will receive that order was successful, then only it will go ahead. Okay,
Mhm.
otherwise it will give you send failure and says that it got failed. Similarly, then payment successful, then it will provide the status, and this status will be received by another API, and then only the task will be done. Otherwise, it will say that the failure, and this failure now needs to be sent to both of these APIs, the payment API also and the order service API also. Why? Because you need to do the rollback tasks. So this is
Okay.
choreography. How choreography works, it depends, like the first thing, the first step you do, then the second step you do. If second step fails, then you need to inform the first step. Okay, and
Yeah.
if the third step fails, you need to inform second and first step both, like that. Okay, so we have another one also, that is saga command orchestration pattern. These things are available on internet. If you want to go through them, you can do that. Otherwise, these are rarely used when doing the practical tasks. Only if the
Oh.
requirement comes up, then only you use this. Otherwise, these are not in use because these are very much complex. Okay, so here what you are doing, you are providing all the details to one orchestrator. Orchestrator is like your that JMS or something, right? So
Mm-hmm.
you are providing the details to only one server, and these details will be picked up from this orchestrator only. But the issue is, let's say this orchestrator got failed, this orchestrator got down, then all will get impacted.
Mm-hmm.
Correct?
Mm-hmm. Mm-hmm.
So these are the differences between these two. Like the characteristic is listen for the successful event from the previous step and the failure event from subsequent steps. As I said, right?
Mm-hmm.
Success from the last step, and if there is a failure, then both the steps. Okay. And in the command orchestrator, listens for the success and failure message from the saga orchestrator. So orchestrator is there which is going to manage for everything. Okay. Next
Mm-hmm.
thing is pros. For this one, the pro is used when coordination across the domains of the control visibility is required. Okay, because we are providing the coordination between these three, right? And pros for this one is used to manage the business processes that are inside one organization. Okay, and centralizes the orchestrator of the transaction. Complexity grows linearly when steps are added. Okay, so if you do like
Okay.
this, for each step you are providing the rollback, or for like you are managing for each and every step, then it will become more and more complex. You will think you will need to create a code for each and everything, right? But this is bit easy, you can reuse the things. Con is adding or deleting the step in the transaction. Let's say you need to add one more step here in between these two. It will become difficult because these two are connected. So you need to just disconnect this and add that, and then create a connection with these two. And then you need to create the failure pattern also, right? So adding a different node, extra node will become difficult. But it is and cons for this one is single point failure, that I was saying, that if it will go down, then everything will be impacted.
All right.
Okay, how these can be implemented. So for choreography, the services execute the transaction and publishes an event to be used by the next service. So you can use JMS, VM, or all to publish the message, to publish the event, basically. Okay, and the saga orchestrator communicates with each service using the command reply style. The orchestrator logic can be modeled as a state machine. Similar to XA pattern, the orchestrator coordinates the transaction. So this is same saga. This is same. I have already explained you from this diagram.
It looks complicated a little bit.
Yeah. Yes. So it says that if you are going to add a new node, new failure message, this one. So it will be easy with the this orchestrator, but it will be difficult with this one. Okay, this is the same slide. So there is one exercise where you need to identify where the transactions can be used, which supports the transaction. Okay, so if you want to take the snapshot of this exercise, you can take it off. Otherwise, we can go ahead. Okay.
Yeah. Let me tell. Yeah. Yeah, I got it.
Okay. Yep. So this is something else. Like in JMS, you have some acknowledgements also. The immediate acknowledgement is there when the consumer when receives the message and sends the acknowledgement to the broker that I have received the message. Okay, no matter it got successful or failed. Next one is auto acknowledgement after the flow execution. If the process fails, then no acknowledgement will be sent, and redelivery of the message by the broker. Next is dupes okay when the duplicates are allowed. Resending of redelivery of messages are allowed. So for this, I don't have any slides. This was just only thing that I could explain. Okay. Next we have module 12. Okay. So in module 12, what we are going to see in the end of this module, distinguish between the competing non-functional requirements. Actually, we have covered these things, but still I'm going to explain this again little bit. Okay.
Mm.
Clarify and validate, because these stuff more and less we have already done here. Okay. Because
Okay.
while doing these modules we were going in deep, right? But so here we will not go in that much deep. Okay.
Mhm.
So clarify and validate the reliability goals for the scenario. Design mule applications and their deployments to meet the reliability. Okay. Identify the reliability pattern for the mule applications. Okay. So what is reliability according to you?
If the data is like all the time available, that's one. Uh, So,
Hmm.
for example, sometimes we have put different places. We put like our server. If one server
Hmm.
might be crash, so
Hmm.
the customer should get on time the actual data.
Hmm.
So we don't need latency. We don't need the data loss, something like that. Every time
Yes.
the data should be available. That's
Yes. But in layman language, reliability comes up when the trust is there. Okay. When you want to maintain the trust, then only reliability comes up, right? In layman
Mhm.
language, that thing is reliable. That means you can trust that thing because that takes the ownership, that takes the responsibility. Correct?
Correct. Yes.
And in technical terms, as you said, that if there will no data loss, there are some disaster management, recovery management is there, and there will be some scalability and everything is there, then we can say that yes, this solution is reliable, we can trust this
Mhm.
solution, right?
Yes. Yes.
So reliability pattern can be implemented in different ways. Okay. So in Mule, how we can achieve that? First one is until successful. Right. As I told you, we have already covered these things. Right. Until successful, we have seen that. Right.
Yes. Yes.
So until successful scope is there, reconnection strategies are there, redelivery policies are there, and this is the error type that comes up with the redelivery policy only. Okay, and the
Mhm.
transactions, error handling, first successful router, everything is there, and it is already written that it is covered in the earlier modules, right?
Yeah.
So now we are seeing that how we are achieving the reliability. So until successful is there, right? So you can provide the number of retries that you can do for the until successful to get the successful response, right?
Okay.
So until successful scope is there for providing you the reliability, basically. Differentiating between the permanent and temporary error types. Okay, until successful does not differentiate between the error types, right? So let's say for one particular error type, for the, let's say for the bad request, you don't want to retry in the until successful, right?
Okay.
Let's say the customer is sending a wrong format of email address. Okay,
Yeah.
so it will get failed, and if you will resend the request then also it will fail, right? So no matter how many times you are going to resend the request, it will fail if the customer is sending wrong email address format, correct?
Mm-hmm. Yes, correct.
So in that case, let's say I don't want to retry, I don't want this until successful to work. So how I'm going to do that? So put everything that is there inside the until successful like this in the try block.
Okay.
Okay, in the try block, and in error handling have one on error continue with bad request, http bad request. Okay, so
Okay.
what it
Okay.
will do, whenever the request will come to this until successful, let's say the customer is sending incorrect email address format, this will get failed, right? This will get failed,
Yeah.
but it is inside the try block, so it will go here and it will see on error continue, and that was a bad request, correct? So this will
Oh.
be followed, and on error continue will give successful, that is 200. So until successful will say, yeah, yeah, go ahead, this is successful, then it will go out, correct?
Okay. Okay.
It will not retry. But in another cases, let's say that it got failed with 504, that is gateway timeout issue is there. In that case,
Mm.
you can see there is no error handling mention. In that case, until successful will do retry with the number of uh, retry attempts that is mentioned in the until successful, correct?
Okay. I
Got
have
it?
one question. So
Mhm.
yeah. So now, uh, so inside until successful, we are
Mhm.
using try block.
Mhm.
So this point every time confuse me. So
Yeah,
uh,
there are two things. There are two things, that is, let's say, let me give you an example here.
mm,
I have this until successful, and I am having a request connector here. Okay.
okay.
And let's say I am sending the student data here. Okay. Hello.
Yeah, yeah.
Yeah. So with this request connector, let's say I am sending the student data to the endpoint. Okay. To XYZ
Okay.
endpoint. And that student data should have four fields. Okay.
Mm-hmm.
It should have four fields. Name should be there, ID should be there, roll number, and your address should be there. Okay, four fields should be there. But what I receive from here is the three fields. Okay,
Mm-hmm.
so I'm going to send three fields which will get failed. Correct.
Yeah.
So I will
Mm-hmm.
do until successful, and until successful, let's say I am having five retries. So it will retry with then that three fields again. It will again get
Mm-hmm.
failed. Then it will try again with three fields, then it will again get failed. So it will try five times, and five times it will get failed with the same error,
Yes.
because we were
Right. Yeah.
sending the same data. Okay,
Mm-hmm.
so in that case, why to hit the endpoint? Because for hitting any endpoint, the cost will be there, correct?
Yes. Yes.
So why to hit the endpoint in that case? So what I am going to do, I will have one try block inside the until successful.
Okay.
Okay, and I will add this request connector inside that try block. Oh, yep. Okay, and in the error handling, I am
Mm.
going to handle only one type of error. Only one type of error.
Oh,
With
connection
on
for
error
example.
continue. On error continue means until successful will receive 200. Okay, because try block will always send, oh sorry, this on error will always send 200 to the parent flow, right? So this
Mm-hmm.
try
Yes.
block, for this one try block, the parent flow is until successful, right? So it will send 200. Okay, so in this on error continue, I am going to handle only http bad
Mm.
request. That is your 400. That is when, if you are sending the wrong data, that means you are sending three fields only.
Okay.
Okay, when user is sending the wrong data, in that case I am just, let's say I am I am just sending the error message to somewhere, or I am raising I am sending the error message. I'm having one transform, and now I am going to, or I'm setting one flag, let's say. So set variable error message, right? So this request connector, if it will receive three fields, then for the first one, first request, it will go and it will receive 400 bad request, and it will go here and it will say 200 okay to the until successful, then it will go out. So when it will go out with the success message, what you can do, you can have a choice router. You can check in this variable, let's say the variable name was error flag, err flag,
Mm-hmm.
err flag, that was one. So you can check if the err flag was one, then do this, send the mail to the customer, correct?
Okay.
But let's say this request connector get fails due to timeout or some other issues, let's say due to authentication issue. Customer is sending username and password, same username and password is being sent, but with that username and password it didn't worked out, but
Mm-hmm.
in next go it worked out due to some
Mm-hmm.
refreshing on the page. Okay,
Okay.
so in that case it will go to error handler and see if the handling is there. The handling is not there because the handling is only there for the bad request, right? So for 401 it is not there, then it will retry, correct?
Okay.
It will retry till 5 times. So this is how you manage in the until successful for which response type you don't want to retry. Okay, clear?
Okay. Yes. So, okay, my understanding. So, when we only use until successful, so
Hmm.
whatever error happening, it's going
Hmm.
to be try to get some or here retry like
Hmm.
whatever
Yes.
time. But when you put try block,
Hmm.
so we
Hmm.
can separate which part should be retry, which part should be exit from the flow. Like only might be
Correct.
one try. Yeah, that's
Correct.
my
Correct.
understanding.
Yes. 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 So you are now defining for which one you don't want to use actually the until successful. In which case you don't want to use until successful. Correct?
Okay, so we defined this inside the error continue. So,
Yeah. So I am defining that for HTTP request, that bad request, that means 400. When the user error, in that case, don't retry. Just go ahead with on error continue. On error continue will give 200.
uh,
Then it until
okay,
successful. Now it is successful. So it will say go ahead.
okay,
It will
got
not
it.
retry. Correct?
Okay,
Okay.
okay, yeah.
Let's go back. So they are also using same type of case. Okay? Sorry.
Okay.
Okay. Next is achieving the reliability with the reconnection strategies. Okay, so there could be some system errors. So here we were discussing about all the types of errors, not only the system errors, not only about the connection errors. Okay, so let's say if there is can be system errors. If you just want to work on a system error, in that case you can have retry reconnection strategies. Correct? So
Mm-hmm.
let's say you don't want to use until successful because you don't want to consider other cases. You just want to consider the connection related stuff. Okay. Then what you can do here, array, so here you have reconnection strategies. Oh, not here. This one. Use the reconnection. Okay. So there are
Mm-hmm.
different types of reconnection strategies. So one is
Okay.
standard one. Okay. So in standard, what you need to do, you need to provide the frequency, at which frequency, sorry, not forever, standard. First of all, we are considering the standard one. In the standard,
Mm.
what I am going to say, that in every 2000 milliseconds, do the reconnection. Try to reconnect, but do only for 2 times. That's it. Okay. So
Okay.
retry will be
Mm-hmm.
done only for 2 times. And here there is a blocking box also. Blocking means block the thread, use the same thread. Okay. If you will
Mm-hmm.
remove this, then you can use another thread also. Okay. You are not blocking the resource, you can say that.
Okay.
Okay. Next one is your forever. Forever means retry again and again after in uh, this every 2000 milliseconds till the successful response will come. Okay.
Mm-hmm. Okay.
This is not recommended. Forever is not recommended because it will
Mm-hmm.
always retry again and again. Right.
Mm-hmm.
So we always try to go with the standard one. So, yep, this is how I have explained and how the connector reconnection strategies work. Uh, out in the Mule application starts anyways and continues to run without any reconnect. However, the reconnection strategy can be configured on some connector operations to instead repeatedly retry, uh, repeatedly try to reconnect. Or the fails deployment attribute can be set to true. Okay. So what you can do, this fails deployment attribute you can set to true to throw an exception if the reconnection attempts fail. Okay, which will prevent the mule application from the starting. Next is redelivery policy. Okay, so these redelivery policies are there for the event sources.
Mm-hmm.
Okay, these are only for the event sources so that you will not be able to send the same data again and again. Number of times the same event can be processed by the flow. Okay, redelivery exhaustive error will be received. So in this case, this one, event processor, in this case you will get the option redelivery. See, so 5 redelivery same event is acceptable only for five times. Okay, otherwise it will not be accepted, you can say that.
I'm sorry, how you put like the count for delivery? So how
Yeah,
do you
here
decide?
you are providing the maximum redelivery count. That means same message again and again. Okay, in the queue, if you
Okay.
are putting same message again and again, then you can put that message 5 times only. 5 times same message. Otherwise, after that it will give failure. Let's say you don't want duplication. So what you can do, only one time or zero time. Zero time means no redelivery will be counted. Let's say you receive one message, say hi, and then you are not allowing that message again, that hi message. Okay, same event again. So to avoid the duplicacy, you are providing the zero value here. But if you want to allow the duplicacy, then you can say -1 also. Okay, -1 means
Okay.
infinite types.
Okay. Where we do use this most of the time? In scheduler
These
only?
are used, no, these are used mostly in the queues part. No, it cannot be used in the scheduler.
Okay, okay, that's fine. Okay. Every time
Okay.
it's new.
Yes, I think in listener also it's not possible. It is, yep, in listener also it's there. Okay. So all the
Okay.
sources. So whatever the source is there, it is possible. Only for schedulers, it is not possible. Okay.
Okay, okay.
Okay. Next is this exercise. If you want to go through this, you can take the snapshot, but I think you can ignore this because this is related to a particular use case, that is Acme Insurance, that we were studying in module 1 or 2.
Okay.
Right? If you remember that one, then you can go ahead.
No, I don't. It's long time.
Okay. And this is this is also the part of the exercise and summaries reliability pattern. Wherever you will see reliability pattern, then your JMS, your VMQs will come up. Okay, because uh, they mostly provides the reliability rather than your listeners. Okay,
Mm-hmm.
your HTTP requests are not that reliable than your that those types of requests which are published
Okay.
and consumed, right? Because
Yeah.
those are remains in the queue. Reliability patterns ensure the reliability in Mule application through the persistent queues across the various connectors. Okay, reconnection strategies allow the connectivity failures to the self heal. Okay, so 12th module done. Now we are on 13th module.
Okay.
So 13th module is designing for the high availability goals. Okay. So this one also we have covered the most of the part. I have shown you the most of the part that is related to the scaling. You remember we have discussed about vertical scaling, horizontal scaling.
Mm-hmm. Mm-hmm. Yeah.
Okay. So it will include the same stuff. Okay. So let's go ahead and see what all is there in this module. So in end of this module, you should be able to clarify the high availability goals for the Mule applications. Okay, so balance the high availability goals with the reliability and the performance goals. So with the high availability, you are providing the reliability and the performance also. Okay, that means if something gets fails, you know that another person is backing up that thing. Okay, so
Mm-hmm.
you can trust that solution and you know that the performance is also perfect. Okay, so identify the ways to achieve HA using the Anypoint platform in Cloud Hub and customer hosted runtime planes. Okay, so how we are going to achieve this? Describe how clustering and load balancing works. Okay, and identifying the HA aware connectors and their design trade-offs. Okay, so I'm going to explain this, but with the coming up of this Cloud Hub 2.0, some few things got changed. I think you are aware of that. Earlier in Cloud Hub 1.0, VMs were there, right? VMs, your workers were there. You're basically
Mm-hmm.
EC2 machines. But now behind the scenes, it uses EKS machine where you are having containers, containerized system, right?
Okay. Okay.
Things got changed basically. But still, I'm going to explain this up because this is a part of syllabus. So HA means higher availability, how to keep the overall system operational when the system components fails. Okay, if one system got fails, then you know that another system is available to handle the request. Okay, high availability is done through the load balancing basically. Okay, in Cloud Hub, you can deploy the Mule application to multiple Cloud Hub workers, right? By this,
Mm-hmm.
you provide higher availability. Next is disaster recovery. Disaster recovery is how to restore a system to the previous acceptable state after a natural or man-made disaster. So let's say you are having customer hosted environment on and your customer data house got corrupted or something happened. Okay. So how you are going to manage that disaster recovery? Okay.
Okay.
It must compensate for the failure of the entire subsystem, regions, zones, data centers, and hence there are large number of systems components that are failed. So mostly what we do if we are having one worker in EU region, okay, so it is recommended to have another one in another region. Clear? So that
Mm-hmm.
if there is any disaster, let's say earthquake or flood or anything will be there in one region, then your data will be there on the second region. When you will search for high availability and disaster recovery in Mule, you will get this one, this link.
Which one?
So you can go through this high availability and disaster recovery in Mule. Just a second. Fetching you the link so that if you want to go through it, you can go through it in deep. Okay, so whatever that is there in the syllabus, I'm going to tell you. But if you want to go in deep, then you can read it out. These are just the numbers and all. Okay,
Yeah.
so this link I can provide you in the chat.
Okay.
Okay, just go
Then
ahead. Yep. So making Mule highly available using the Mule runtimes. So it comes with horizontal scaling and vertical scaling. Now I'm going to explain that. I think you are already aware. You remember that horizontal scaling, that means we are increasing the number of workers. Okay. Vertical scaling
hmm
is when you are increasing the size of the worker. Okay. Horizontal
Okay.
scaling comes up when you are having high load. That means if your server can accept only 100 requests and you are getting 1000 requests, okay,
Okay.
in that case you can have what you can have horizontal scaling. But in case of larger file, if you are getting the larger file in the request which is more than your ram size, okay, that means you
hmm
need to increase the ram size, right? So in that case you need to increase the size of a worker, so that is called vertical scaling.
Okay. Okay.
Okay, just give me a second. I think I'm having some issues with my headphone. Hello.
Yeah, I can hear you.
Okay, now it's correct. Okay, so horizontal scaling for multiple mule runtimes, okay, process on multiple concurrent physical machines or workers. As I said, that horizontal scaling means multiple workers. Okay, so HA goals for the customer hosted environment or the runtime fabric can be met through the load balancing or the clustering. Okay, so you know what
Mhm.
is load balancing? You are having multiple workers, okay, and if you are receiving 1000 requests but your one worker can handle only 100 requests, so load balancer will see which worker is available to take the request. It will send the request based on that, okay, and it will balance out the load. So there are some algorithms which are being used inside the load balancer to send the request to the workers.
Okay. Okay.
Okay, same goes with the clustering, but inside in clustering what you will do, see, there is a difference between clustering and load balancing. In load balancing, each and every system, each and every worker will have their own memory, right? See here, it is having
hmm
its own memory. But in clustering, every memory will be the memory
Sure.
will be shared. Okay,
Okay.
so next one is Cloud Hub provides HA features such as shared states and the load balancing capabilities, right? So achieving the HA and Cloud Hub using load balancing between the Cloud Hub workers. So HA can be achieved by using multiple Cloud Hub workers, that is horizontal scaling. Okay, so workers do not share any memory. It is easy to configure. Workers can use the external system for the state management also. Okay, so you remember that v2 thing that I told you at that time, that object store v2, right? So
hmm
in that case workers were storing the data inside that v2, that is object store that was managed by the Cloud Hub, that is not the part of your worker. Okay,
Mm-hmm.
so workers will be spread across different availability zones in the same AWS region. Okay, sorry, at that time I told you that it should be in different regions. Actually, it should be in different availability zones. Okay, so in one state, it could have multiple availability zones in one country. Sorry. Okay,
Okay.
so multiple application data can be shared between the workers using object store v2, as I told you. Okay, and VM queues with the persistent queue enabled in the runtime manager. Okay, with the VM queues also you can share the data. Next is load balancing in Cloud Hub. Load balancing for HTTP connector, HTTP or HTTPS connector, and HTTPS connector requests are automatically load balanced through the shared or load dedicated load balancers. Okay, so Cloud Hub provides both the cases. Shared load balancers are used already in use because you are just doing the horizontal scaling. You are not creating your own this load balancers, right? So balancers are already there, which are with the Cloud Hub only. Okay, so but for the dedicated one you can have that, but inside the VPC only. So if you are having VPC, then only you can have dedicated load balancers.
Can you explain for me for about load balancing, how we're going to implement in the Cloud Hub?
Yeah, I explained that in module I think 3 or 4. uh,
Yeah, but
okay, let me tell you that again.
so when you explain something, I have confused with the uh,
So I'll delete. Okay, so these are your workers, these are your machines. Okay, so these machines are having same code. Okay,
mhm,
same application. Let's say this proj1 is deployed here also, here also, here also. Okay,
it's the
so
same
you are
data.
just,
Yeah.
yes, same data, because while deploying
Okay.
you mention na how many workers you want to use.
Okay. Okay.
You don't remember that. Okay, let me tell you how.
Which one? Uh,
Let me tell you.
okay.
Oh shit. Uh, just give me a second. I need to bring my phone. Okay. So whenever you deploy any application here, okay,
Mhm.
so we usually define how many replica count. Replica count means number of workers. Okay, in Cloud Hub 2.0 we have replica count, or and in Cloud Hub we have number of workers, right?
Yes. Yes.
This thing is horizontal scaling. That means you are deploying the same code on 2 workers, same code on 3 workers, same code on 4 workers. Okay,
Okay.
so if you have deployed the same code on 3 workers, okay, same code on 3 workers, so what Cloud Hub uses, Cloud Hub have the shared load balancer.
Okay.
So whenever this application will receive the request, the shared load balancer manages like how to send the request, to which one to send the request. It balances the load. It sees
Mm-hmm.
which worker is available to take the request. Okay, so some algorithm, some calculations are being used in this load balancer. So this is shared load balancer, you can say SLB. Okay, but let's say customer says that I want to use my own host name. Rather than using this host name that is provided by the cloud hub, I want to use xyz.com.
Okay.
Plus I want to use my own certificates for
Okay.
two-way uh, two-way handshaking.
Okay.
Okay, so in this case what it will do, it will create, we can create a DLB, that is dedicated load balancer. So this is
Okay.
not free provided by cloud hub. Okay, so customer needs to take the license for this, take the customer needs to pay for this DLB. Okay, and
Okay.
customer cannot buy DLB itself. Okay, so they first need to buy VPC, that is virtual private cloud. Inside VPC only they can use DLB. Okay,
Okay. Okay. Okay.
so this is what I was explaining. So it is dedicated load balancer, dedicated for this particular application. So you can say PJ1, PJ1, PJ1. Now customer can use their own this one and this one. And even you can by using the VPC, you can restrict the IP addresses. You can add so many rules here. Okay.
Okay. Mm-hmm. Mm-hmm.
Okay. So
Yeah.
let's go back. So load balancing for VM connector in the Cloud Hub, each persistent VM queue is listed to be every Cloud Hub worker. Okay. So whenever you are having multiple Cloud Hub workers like this, okay. So how your VM queue will be shared? Uh, how it will be doing the load balancing? Okay, but each message is read and processed at least once only by only one cloud hub worker, and duplicate processing is possible. So if cloud hub worker fails, the message can be read by another worker to prevent the loss of the message, which
Mm-hmm.
can lead to duplicate messaging. Okay, so what it do, so since let's say if you are having three workers and all three of them will be having a VM queue, persistent queue, right? So
Okay.
whenever the message will be sent, only one VM queue will take the message. Okay,
Mm-hmm.
only one of them can listen the message. Okay, let's say your source is JMS here, right? Let's say your source is now mm, VM list. Mhm. Let's say VM listener is there. Okay, so any of your worker can listen that message, right? So any of the VM queue will listen that message. That's what it is saying. Okay, but let's say it listens the message, but the processing got failed. In that case, another VM will listen the message. Achieving the higher availability goals in customer hosted runtime planes. So this is what we were discussing about the cloud hub. Now we will see how in the customer hosted runtime planes we achieve the higher availability. Okay, so
Okay.
comparing the mule runtime groups versus the server groups versus the cluster. So there are two things, first one is server group and another one is your clustering.
Okay. Okay.
Just a sorry. Server group is just an administrative grouping of isolated mule runtimes. Okay, so these are different runtimes. Server group, that means different servers are there. Okay, so customer is having one server uh, that is there in US and another server that is there in India. Okay, so they want
Mhm.
to make a group of these servers. Okay, so that the data can be shared among these groups, these servers. So in that case, you can create server groups. Okay, but we have clustering. Clustering is possible only for one server. Server is there, but you are having different applications. In that case, you can have the clustering. So cluster provides additional guarantees to prevent the contention between the mule runtimes. The file access by file-based transports. All JMS topic subscribers connect to the same topic and resulting in duplicate processing. You can take the snapshot for this. This
Okay.
is just the theory part, and I remember I have already covered this in these modules. You can go through the recordings also to
Okay, I will do
to
that.
check that out. Okay, other than that you can take the snapshot for this slide. This is just the theory part. Okay, so in every server group, okay, every server will use its own object store. It is unclustered. Okay, in clustering you know that the memory will be shared, object store will be shared. Okay, so this is also known as unclustered load balancing for HA and the performance in the customer hosted runtime planes. Multiple Mule runtimes are configured to run the same Mule applications. Okay, different Mule runtimes. That means one server is there in India, one server is there in US, but then both are running the same application. That is Proj one. Proj one is there in both the servers. Okay, and runtime fabric allows the choice of this per application deployment. It does not share or synchronize the data between these mule runtimes. So in case you are having unclustered load balancing, that means if you are using server groups, then it will not be sharing or synchronizing the data between these mule runtimes. Okay, could be potentially lead to processing the duplicate or lost messages. Okay, so let's say if you are having a server group and you are sending the request to both the servers, then it will do the duplicate processing. Okay, and if you are doing some changes on one server, it will not sync with another server, which will make the loss of messages. Okay, but using
Mhm.
the shared database or message broker and other systems, this thing is possible. Then you can uh, like you can prevent this data duplicate data processing and loss of messages if you are using some shared database. Let's say if there is any external database that you are using, in both the cases, then you can prevent this loss of messages between these two servers. Messages must be distributed or load balanced. Okay, so messages should be always load balanced, so load balancers should be used. Achieving the HA using the customer hosted clusters. Now cluster is topic is there. A cluster is a set of the customer hosted mule runtimes that act as a unit. Okay, so it everything will act as a unit because everything is connected to each other. The servers in cluster communicate through the distributed shared memory. So in clustering, you can say that in clustering, the memory is shared, but in server groups, the memory is not shared. So this is the main difference. Object
Mhm.
store and VMQ state is replicated among the memory across the memory in different mule runtimes. Okay, so this will also be replicated. The cluster nodes can be configured to be more reliable, so they also copy the data to an external database. You can also have an external database where you are having the all the data so that the backup will be always there.
Mhm.
Here the nodes are aware of each other. So if one node goes down, another node will get to know that one node is down. Okay, that means let's say if there are three nodes in the cluster and one node goes down, another two will get to know that one node is down. Okay,
Mhm.
all the cluster nodes work in active active, and there is a primary node which where the schedulers and GMS listeners will run. Okay, so there will always be a primary node, because you don't want that, in case you are having a VM queue, you don't want every worker will accept the message, every server will accept the message, right? The message should be accepted once and processed once. There should not be duplicate processing, right? So there will be always a primary node on which the scheduler and this JMS listeners will run. Okay, because if the scheduler will be there in all the workers, let's say here in the example, in this example, if we are having one scheduler here, here, and here, if all
Mhm.
will run, then there will be a duplicate processing, right?
Yes, yes.
So what we will do, we will be having clustering. In clustering we have one primary node, so let's say this worker 1 is primary node, and then we are having worker 2 and worker 3. So everything like scheduler and JMS listener, that is event based, will run here in worker 1.
Mhm.
Okay, and if it goes down, we have another worker which is available, then it will run in W2, not in W3. Okay, so whichever
So,
will be
sorry,
picked
I
one.
have one question. So in W2, so if it is active and if the primary is like down,
Hmm.
so 2 and 3 are passive, yeah, not active. So
Hmm.
uh, how do you know like 2 is like working, like So
Yep.
how are we going to
Randomly,
see?
yeah, randomly, one of these will be picked as a primary node at that time.
Oh, okay.
Then that will be considered as a primary node, and once this will get active, then it will be not prime non-primary. Okay,
Wherever is ready is active, yeah. So
yes, yes, which
okay.
is active, and randomly it will choose.
Oh, okay.
Okay, so manage the peak loads. Nodes can be added or removed from the cluster. Available for customer hosted mule runtimes and runtime fabric deployments, so it is not available for cloud hub deployments, that you should be aware of. Okay, so how clusters survive the failure of the mule runtime? So here it is going to explain the same thing. Okay, if one mule runtime fails, the outside VM queue messages will be processed by surviving nodes in the cluster, so are still available. If the failed node was primary node, so if the primary node gets down, then one of the remaining nodes is selected as a new primary node. Okay,
Okay.
clear?
Yep, yep.
Which will run schedulers and the primary node only configured event sources. A cluster can be tuned to be either performant or reliable. Okay, so either you can focus on performance, either you can focus on your reliability. It can be configured with the quorum count. Quorum count is like the cluster is not available until the minimum number of nodes are available. Okay, so let's say we have one quorum. We decided that if two nodes are pick, minimum two nodes are pick, then this system is up. Otherwise, you can say that system is down. No matter if one node is up. Clear?
Mm-hmm. Okay.
So we are providing the minimum number of nodes that are active. Okay. So determines how many nodes replicate the data, and we are providing that how many nodes can replicate the data at particular time.
Mm-hmm.
So, yep. So quorum count, you can say that minimum nodes to be up to see that the cluster is working. Let me provide you this in the chat. Okay. So how customer hosted Mule runtime joins the cluster? Okay. So cluster are either multicast or unicast for discovery of other nodes. Okay. So what is the difference between unicast and multicast, that we are going to see here? Just a second, sorry. So for unicast, it uses the IP addresses for identifying a server. Okay. Since in a cluster we always have multiple nodes, multiple workers are there, right? Multiple servers are there. So
Mhm.
it identifies by using the IP addresses. But you should remember that IP addresses can change, right? IP
Okay.
addresses can change anytime. So in case you are having static IP addresses, then only prefer for unicast, because unicast uses IP address to identify the server to which it wants all
Mhm.
the servers that are connected. Next is multicast. Multicast cast is nodes automatically detect each other. So in multicast, in the backend only they are able to detect each other. Like the rule is not defined, so they are not based on the IP addresses. We are not providing them the linking, so they are automatically detecting. Clear? So for
Now,
unicast, uh,
so
see, we have
what's the
two types of
difference?
clustering. First one is, so here we are having three nodes, right?
Mm-hmm.
So in the cluster, one node should be aware of other nodes, correct?
Mm-hmm. Yep.
In load balancing and in server group, these should not be connected. They should not be aware, right? But in clustering, they should be aware. This worker 1, let's say this is worker 1, this is worker 2, and this is worker 3. So they should be aware of these two. So how they are going to be aware, how they are connected? So in unicast, they are aware of each other by using the IP address. So IP address of this
Okay.
worker 2 is there in IP address of sorry in the settings of this worker 1, like that. Okay, these are
Mm-hmm.
identifying each other based on the IP addresses. That is called unicast. Okay.
Okay.
Second one is multicast. For this multicast, you don't need this IP addresses. You are just saying that worker 1, worker 2, worker 3, they are get automatically connected.
Okay.
Clear?
Mm-hmm. Got it.
So in unicast, what are the pros? What are the advantages? No special network configuration other than the IP addresses. So we know that the link is through the IP addresses. That means we don't need to do any other configuration. We don't need to tell them that you have to identify by this and that. Right? Only IP addresses will be configured. But in multicast, nodes dynamically join the cluster when the node is started. Okay. So here we are aware which node we are going to join, right? But in multicast, the things are not in our hand, basically. They are dynamically joining the cluster. You are saying that this is the another node. And when the node is getting started, it is getting joined. But here, since if the IP address, based on the IP address, you are joining that particular node. Okay. Next is cons. Cons is IP addresses of the least one other nodes must be known. So IP addresses should be known by the other workers in this case. So this is the
Mm-hmm.
disadvantage, because IP address can be changed also. Correct.
Yep.
In
Mm-hmm.
multicast, only the permitted in the network where multicasted is allowed. Okay. Since multicast multicast will be using some different types of configuration, so it is not allowed everywhere. So wherever this multicast is allowed, there only you can use this. So this is the disadvantage. Okay. Next is how the shared memory is used in the cluster. Okay, so a cluster uses Hazelcast. Okay, it uses Hazelcast to create a distributed shared memory grid. Just give me a second. Drink water. Okay, how to get the page numbers here from the insert?
Uh,
Yeah,
well,
here, bottom of the page, like this. Okay, this is 224 page number. Okay, so 14th is on 2:32. So we can finish this, right? So we can finish this and then we will do the another one tomorrow. Yeah.
Okay.
Okay. There are so many things. Okay.
Yeah.
So a cluster uses Hazelcast to create a distributed shared memory grid. Okay. Or if you're thinking that everything is going like above your head now, we can wrap up today. Then we can start it tomorrow. Because I think only 2 days are needed now to cover this.
Okay.
That's
Okay.
it.
So yeah, it's too much information. Yeah.
Yes, yes. So
So I
even I
think
can like I got tired by reading again and again because everything is theoretical, na? So
yeah,
yeah.
yeah, sure. Yeah, you're right. So we can continue tomorrow.
So what is another module? Let's just see the headings. What are there so that we will get to know what we have already covered, right? So optimizing the performance. So next one is related to the performance. How we are going to like manage the performance and all.
Mhm.
So it will be like the monitoring dashboards. So that's it. And what is there? Yeah, we have covered this batch scheduler, event messages. Yeah, and we can just ignore this one. Transformation, scatter together. Wow. So we have
Yeah,
already covered
performance.
this.
Yeah. Mhm.
So, yeah. So what is there in module 315? That is designing secure mule applications and deployments. So now we are going to provide the security, na? Some security feature. Okay. The security stuff is also like very much theoretical. It's theoretical part. Yep. Okay. Next is your